Hi and welcome to this video on our ESP range of sensors. Before we start, click the subscribe button and then the bell icon to be notified of all of our new video content. If you're at all familiar with the Hochiki brand, you'll know that we started in Japan over 100 years ago and we're probably best known in the industry for our fire detectors. After all, that's where we started. Now that small company has grown into a global group which has diversified into all kinds of life safety systems. But after 100 years, we like to think we still manufacture some of the best sensors on the market with our addressable ESP range. First of all, a quick explanation of the term ESP. It stands for Enhanced Systems Protocol, which is actually the name given to Hochiki's Open Protocol, a communication platform at the heart of the entire analog addressable range. ESP is one of the most robust platforms on the market, packed full of features that will support extremely complex systems whilst providing reliable, error-free operation. Our ESP sensor range has been designed to make the most of the ESP protocol and consists of 4 types: an optical smoke, a heat, a smoke and heat multi, and our newest addition to the range, the smoke, heat and CO multi. The basic range is supplemented by a series of special application variants, each designed with a specific environment or application in mind. These include marine approved, SIL capable, and even versions with built-in short-circuit isolators. Aesthetically, the range has been designed to be unobtrusive with a simple twist-fit connection between the sensor and its base. The sensors and bases are also available in ivory, white or black to suit most environments. Subtle case markings indicate the type of sensor, making it simple to identify from ground level. There are also twin LEDs, which are bi-coloured, green when polling and red in an alarm activation. These LEDs are tri-coloured on the SCI versions, also turning amber when the isolator is active. Sensor addressing is achieved electronically through the use of a TCH-B200 programmer, and the address is stored in the sensor. And a special feature of the ESP protocol is its ability to extend the loop addressing when a sensor is combined with one of our base sounders or base sounder beacons. More on that in a moment. Inside the smoke and multi-sensors is a specially engineered chamber housing the optical sensing elements. It's designed to let smoke in, but to keep out ambient light. The basic detection principle here is called backscatter, where light reflected off of the surface of smoke particles is detected. Hochiki have developed optical technology that can analyse a wider range of smoke particle types, including those previously only seen by ionisation sensors. Inside the heat and multi-sensors are thermistors, sensing elements that are extremely sensitive to heat change. The sensors can be programmed to react to either a rate of rise response, fast increases to heat, or a predetermined temperature threshold. The newest multi-sensor, the ACD, also features a CO sensing element, which can detect CO when released at the very early stages of a smouldering fire, before visible smoke or flames. But this sensor can also recognise the threat of carboxyhemoglobin toxic poisoning, commonly referred to as carbon monoxide poisoning. Now, this is usually suffered as the result of either a sudden high exposure to CO or prolonged exposure over time, so the ACD comes equipped with operating modes that monitor for both. Our ESP sensors have the ability to have their fire threshold adjusted to suit certain environments. In this way, we can increase or decrease the sensitivity of the optical chamber based on percent of obscuration per metre, or the temperature in degrees Celsius in the case of a heat sensor. Adjusting the threshold to 1%, its maximum setting, sets the chamber at its most sensitive, as it requires less percentage per metre to be obscured. If we increase the threshold to 5%, its minimum setting, this sets the chamber at its least sensitive, as it requires more percentage per metre to be obscured. These settings can be adjusted for the individual sensor directly at the fire alarm control panel or by using specific programming software. The default settings for an optical smoke sensor is 3% and for a multi-sensor it's 4%. Another of the features of the ESP protocol is its ability to apply drift compensation to the sensors. This is a useful feature that keeps the sensor working to its optimum by allowing the electronics to shift the fire threshold level and baseline if the chamber and optics become contaminated over time. The majority of our ESP sensors fit onto our standard electronics-free base, the YBN-R3. This simple base is perfect for installations where you need to run cables at first fix and then come back to fit the sensors at second fix. The sensors with integrated short-circuit isolators require the YBV-R4 base to enable the SCI function. The sensors will also fit directly onto our range of base sounders and base sounder beacons, and when combined like this, the sounder bases auto-address themselves using the attached sensor address. For example, if the sensor had been addressed as 10, when added to a sounder base, the base's address would automatically be set at the sensor address plus 127. In this case, this would be 137. In this way, the features of the sounder base can be independently controlled by the fire control panel via the ESP protocol. And this is the same for the base sounder beacon. Thank you for watching this video on our ESP sensor range. We hope it's been useful. For further information, please visit our website at the address coming up on screen in a moment. And don't forget, you can also follow us on LinkedIn, Twitter and Facebook to keep up to date with our latest news. See you next time.